Now, question number 2. This is one of the questions that was posted by our subscribers. So the question reads, refer to the figure showing a parabola y is equals to f of x equals to ax squared plus bx plus c, and a straight line y is equals to g of x is equals to mx plus k. That was my cursor. Okay. And then the first question, the graphs intersect at the points D and E. Determine an expression in terms of a, b, c, m, and k for the x-coordinates of these points. So we are given two functions. One is a straight line and the other a parabola. And these two functions intersect at D and E. And we need to express these x-coordinates, x at D. Okay. We need to express x at D and x at E in terms of those unknowns and variables. Okay. So just like any other equations whereby we're given two functions and we need to find where they're equal or where they intersect, we just equate the equations of those two functions. In this case, f of x is equals to g of x. Now let us substitute. We have ax squared plus bx plus c, that is equals to the straight line mx plus k. Now let us simplify this by taking or transposing everything on the right to the left. So I will have ax squared plus bx. Then I'll write the mx next to the bx because these are like terms. Okay, let me create enough room. And then plus c minus k, all of that is equals to 0. We can further simplify this and say ax squared plus, I'll factor out x, and then I'll remain with b minus m multiplied by x, then plus c minus k. So notice that this is a quadratic equation and it is in standard form. That's our value of a, and then this will be our b, and this is our y-intercept, the value c. So this quadratic equation, if ever we find the roots of this equation, the roots of these equations will tell us the x values where these two functions intersect. And since we have variables and unknowns, so we can only use a quadratic formula in this case. So we'll have x is equals to minus b, or rather, let me rewrite the quadratic formula. B squared minus 4ac. All of that divided by 2a. Now we'll substitute our value of a, b, and c into this quadratic formula. And I will keep it with plus minus, so I will not write both solutions. So instead I'll just say minus and then substitution for my b, that is b minus m. Then I'll keep that our first solution, it has a plus, and the other solution will have a minus. However, both x values will be positive if ever like we had whole numbers instead of a, b, and m, because both our x values are to the right of the y-axis. And then our discriminant will still have b minus m all square, then minus 4. Our a, it's a, then our c, it's c minus k. All of that under a square root divided by 2a. So in fact, this solution is not just x, that is the x value at D and at E. So that's how we can present our x coordinate at those two intersections. And then the second question, M is the midpoint of the line segment DE. Determine a simplified expression for the x-coordinate at M in terms of A, B, and M. So we have a line segment DE, okay, which is this line, and then at M we're told that that is a midpoint, and we need to find the x-coordinate at M. So the formula for the midpoint, we can just say the midpoint at M, we can say x1 plus x2, all of that divided by 2. And for now, our only concern is the x value, so I will not write for the y values. And our x values will use the x's, the x at D and the x at E, our previous solutions. So, okay, because this will be, we have a lot of unknowns and variables, so I'll just create a variable that will present my discriminant. So instead of writing everything under that square root, I'll just say delta is equals to my discriminant, which is b minus m all square minus 4a into c minus k. So everywhere where I have that, I'll just substitute this delta. And please, if ever like you are in a formal assessment, write everything in full. For here, I'm just trying to save time, and I don't have enough room to write on. So yeah, just write everything in full. So our x coordinate at M, okay, the first one, let's just say we'll take minus into b minus m, then say plus, divided by the square root of delta, which is that, and all of that is still divided by 2a. This is our first x value, then plus negative, okay, I need another bracket, into b minus m, then minus second solution, the square root of delta. All of that is divided by 2a. And then that whole expression is still divided by the value 2 from the midpoint formula. And now let us simplify that expression. Our denominators are the same, so we can just add the numerators. We'll have minus into b minus m plus the square root of delta, plus times a minus, that's a minus, b minus m, right? And then negative times a positive, that's just going to be a negative. Okay, it's still a negative, square root of delta, divided by 2a. And all of this is still divided by the value 2, so we can just say times a half. Okay, our deltas will cancel because we've got plus delta and then minus the square root of delta. These two will cancel, and then these minus, and then in brackets b minus m are like terms, so minus 1, that's just minus 2 into b minus m, and all of that is divided by 2a multiplied by a half. So the 2's will cancel, and then let me just write that here. Okay, let's just substitute in our half. So we'll have minus b into b minus m, and then we'll have 2a. Then we can rewrite this as m minus b divided by 2a. So this is our x value at that midpoint. It is presented by the value m minus b divided by 2a. So we have m minus b divided by 2a. And then the third question, P is a point on the straight line between D and E. Okay, Q is on the parabola with PQ a vertical line. Write down an expression for PQ in terms of A, B, C, M, and K. So we are told that we have that point P that's on that line segment D, and then Q is on the parabola. So in other words, we are required to present this vertical distance PQ in terms of our variables and unknowns. So okay, whenever like we have a situation where we want to calculate the distance between two functions, we just find the difference between, let us say, the y at P minus the y at Q. The y at Q. Okay, I'm making this more untidy. So here we'll just compute the distance of P and Q, meaning we'll just say question is this. Question 3, 11.3. So we'll just say PQ, the distance PQ is presented by the difference of the straight line, which is g of x minus the parabola f of x. So we can say that's mx plus k minus our parabolic function ax bx plus c. So let's just let me just expand this, plus k minus ax squared minus bx minus c. So notice that the distance of PQ, we can just write that, let us say PQ is a function of x. PQ of x is presented by that function. So we can further simplify and say ax squared, it's plus our like terms mx and bx. So we have m minus b multiplied by x. Then we have plus k minus c. So this is a function of x. Our vertical distance PQ. Is that all? Let's see. Yeah, we just need to write down an expression for PQ. Yeah, so we've presented PQ as a function of x. And then question number 4. G is the turning point of the parabola. Show that FG is equal to 4k minus 4ac. Okay, all of that. Now we are required to present the distance of, or rather, yeah, what FG is in terms of those variables and unknowns. So FG, that's our line, that's our vertical distance from that point F up until G. And at this point we have a turning point. That's our parabola, and we have a turning point. So in other words, we are required to prove that that vertical distance FG is equal to that. Just for 3 marks. Interesting. Okay, so in this case we'll use our previous solution, right? Our previous solution being the function of PQ of x. The reason being because, okay, these two, they're just parallel lines, and both of these vertical distances, it's just the distance between our straight line and our parabola. And we can use the function definition of P of x to define f of g. That's because the only difference is our x values that we have here. Let us name this x value. Let us say we have v. If ever we take the x value here, v, and substitute into this function of pq, we will get the vertical distance from P to Q. And then if ever we substitute our x value here, let us name that u, into this function of PQ, we will get our vertical distance FG. So this presentation of PQ is not only exclusive to those 2 points, it's still applicable for FG, because if ever we try and find what FG is, we'll do the same thing and say mx plus k minus this parabola, of which will end up with the same function. Now the only difference is the x value that we use to find the distance from f to g. So I will say the function of PQ of x, it's the same as the function of FG of x, right? And then it's that whole equation, but in this case we'll substitute our x value at g. And why are we using that point? It's because that's the only location where we've got enough information to know what our x value is there. And we know the equation of a turning point, that it is given by, or rather the formula to find our turning points. If ever we know the equation of the parabola, we can use minus b divided by 2a, and then for our x value we can use that's minus b squared minus 4ac divided by 4a. That's how we can find our turning points. And using our, where's our, okay, our f of x, we know our f of x is already ax squared plus bx plus c. So for our x value at the turning point, let's name that x at g. I think I need to use a different colored pen. Okay, let's just say for our x at g, using this formula and my equation, we'll find that what's our b? Our b is still b, so it's minus b divided by our a, it's a, so we've got 2a. So we can take this value of x at g and substitute it into our function of fg of x to find the distance between f and g. So even fg is defined by that quadratic equation. So we'll say now let me do my substitution here. So f of g of minus b divided by 2a, and hopefully we're able to prove that fg is equals to that value that we are given there. So we've got minus a, and then our x value is squared, so minus b divided by 2a, all of that is squared, plus the difference of m and b multiplied by our x, which is minus b divided by 2a, and then plus k minus c. So for now, let us handle our squares, and I'll try not to expand this much, just so that I don't confuse myself. So okay, here I will have just a b squared and then a 4a squared, and the a's will cancel. Yeah, so in other words, we'll remain with just b squared divided by 4a. Okay, I still have a negative, right? Let's see. Yeah, because the a's will cancel. I'll have positive b squared divided by 4a squared. Yeah, I'll still have a negative a there. And then plus, should I multiply this? Okay, let's just keep it that way for now, because this is going to be too complex, and yeah, let's just keep it as multiplied by negative b divided by 2a then plus k minus c. And now to simplify this, I'll take my highest common factor, I'll multiply everything by 4a. So we have minus b squared multiplied by 4a. The 4a's will cancel, and then we just have plus. And then this whole product multiplied by our highest common factor. So we'll just say m minus b. And I'll just multiply this first value, 2a, multiplied by 4a. And then I'll just say 4a multiplied into k minus c. And all of this is divided by our divided by 4a. So to simplify this, the a's will cancel here, and then we'll have 2 there. Yeah, for now, let us just keep it simple. Let's not, or rather, let's see. Okay, since here I will have b squared, so I can expand, I can multiply minus 2b into this, but then that I will leave it as is. So we have minus b squared, then minus bm minus, okay, that's going to be a positive. It's a 2b, not just bm. I have a 2 there, so it's a 2bm, then it's going to be positive 2b squared, then plus 4a into k minus c. All of that still divisible by, divided by 4a. So our like terms, we've got 2b squared, so minus 1 plus 2. I'll just have b squared, and then minus 2bm plus 4a into k minus c. All of that divided by 4a. Yeah, we cannot further simplify that, so this should be our fg. We have 4ak minus 4ac minus 2bm plus b squared. 4a, so yeah, we can expand this and say 4ak minus 4ac. Yeah, we roughly have the same solution. So you can just multiply out this thing. You should have an identical solution to what we are given there. And then question number 5. PQ is to be maximized. Show that the x-coordinate that yields the maximum length is at m. So the previous equation of PQ that we found at question number 3, we are now told that PQ is to be maximized, and we need to show that the x value that maximizes that function we found is at m. Okay, so remember that we presented PQ as a function of x, and now we are told that this function will be maximized, and the only value that can give us a maximum value, it's the x value of m. We need to show that. So in other words, we are not just required to take the x value at m and plug it into this PQ of x, but rather we need to show that the x value that can maximize this function is the one that is equals to the x value at that midpoint. So how can we prove that? Let me write this and say my question, or rather let me say maximizing. So whenever we have a quadratic function and we need to find its maximum, what we do, we take the first derivative of that function and then we equate it to 0. Let us say we've got a quadratic function q of x. Obviously it's going to be ax squared then plus something, let's say plus k. Okay, let's make that function minus, right? So the shape of this function is like this, and the maximum value of this function is at that point where the gradient is 0. So we'll take the first derivative of this function and then equate it to 0, and we find our x value there, because that point is the maximum. So we'll do the same thing with our pq of x. We'll take the first derivative of pq of x, and there's my equation of pq of x there. So deriving that, I will have minus 2ax, then plus the derivative of my b, that's just going to be m minus b, and then I'll equate that to 0. We have 2ax plus m minus b. Now let's just solve for x. 2ax, then minus b. Divide both sides by 2a. So look at that. Now our x value is equals to m minus b divided by 2a. And this value, this x value, is equals to the x, our x at m. Our x at m is m minus b divided by 2a. So after finding the first derivative, we are getting our x value the same as that x value of the midpoint. So we've proved. And then the last question, hence show that maximum PQ is equals to m minus b squared plus 4a into k minus c, all divided by 4a. So in other words, we are just told that show that the maximum value, it's that value. Okay, we know what the x value is. We just need to substitute our x value into our original function. So we just need to substitute in our function pq of x, that value of x. Let me just call that x at m. So I'll just say x at m into my original function. So I don't have space. Okay, hopefully I remember. Let's say minus ax squared. So I will have minus a into x squared, which is so we'll square m minus b, all of that is squared, then plus we had m minus b, then multiplied by x. So we'll have m minus b multiplied by our x value, m minus b divided by 2a. Then we have plus k minus c. Yeah. Now let's simplify this expression. I'll just say minus a. Then I will not expand that. I'll just keep it simple. And then this will be 4a squared. And the a's will cancel. Okay, let me just erase that. So we've got a negative there, and then we have just 1a. And then we've got like terms, so I'll just write that as a power of 2. So m minus b all square divided by 2a. And then we have k minus c. Yeah, I can further simplify this by multiplying everything by the highest common factor. So this whole expression multiplied by 4a, the 4a's will cancel, so we'll have m minus b all square plus these multiplied by 4a. Okay, we'll have a remainder 2, so we'll have plus 2 there, and then the a's will cancel, m minus b all square, and then multiply this by 4a. then all of these is divided by 4a. So we can further simplify because there are like terms there. We've got 2, these powers of 2, so minus 1 plus 2. That's just m minus b all square plus 4a into k minus c. All of this divided by 4a. So this, okay, this is the maximum value. Yeah, the maximum PQ. So this is our PQ, our maximum value.